We walk on it every day, right? But how often do we actually, stop and think about the ground beneath our feet?
Yeah.
I mean, we know Earth is our home, obviously, but what if it's more than just this, I don't know, hunk of rock we happen to live on? What if, and stick with me here, it's actually alive?
It's a question, people have been kind of pondering for centuries, but the exciting thing is that modern science is giving us this whole new way of looking at how connected life is with this planet.
And that's what we're really diving into today with Ferris Jabr's book, Becoming Earth. I gotta admit, when I started reading this, I was like, okay, how lively can rocks and dirt really be? But Jab, he throws some serious curveballs at you. He's actually making a case for Earth itself being a living thing, and not in some kind of mystical way, but based on actual science.
Yeah, it is a fascinating way to kind of flip your perspective. You always talk about how environments shape life, right?
Right.
But what if we flip that around? Jabr is really digging into how life, from the tiniest little microbes to those massive creatures we only see in museums now, how all of that has actually shaped Earth into what we see today.
It's wild. Okay, so think about the Grand Canyon. It's awe-inspiring, right?
Oh, absolutely.
We picture this huge gorge carved out by the Colorado River over, millions of years. But what if I told you that microscopic, tiny little miners played a part in shaping that whole landscape, too? That's the kind of stuff we're talking about.
Yeah, it's all about scale, right? We tend to focus on the big, obvious stuff. But a huge amount of Earth's biomass, the actual amount of living stuff, it's not even on the surface. It's deep, deep underground.
Deep underground. Okay, how deep are we talking? And what kind of life could even survive down there?
So picture this, okay? Miles below the surface, pitch black, crushing pressure. You've got this whole world of intraterrestrial microbes just thriving.
Wow.
And these aren't your normal, oxygen-breathing, sun-loving organisms. They're eating rock, breathing sulfur, basically living in conditions we thought were totally impossible.
Eating rock. Okay, that's hardcore. But how can something so small, living so deep down, actually have any impact on the whole planet?
Well, it's a long game, right? Imagine these microbes over billions of years just slowly, steadily breaking down minerals, releasing nutrients, changing how water moves through the Earth's crust. I mean, they might have even helped form the continents themselves. It's crazy.
Okay, now I'm really starting to see how this ties into the whole Earth is alive idea. It's not just life existing on Earth, it's life woven into the planet itself.
Exactly. And it's not just these tiny miners either. Job talks about megafauna too, those giant animals roaming Earth during the Ice Age. He uses the example of the mammoth steppe, this huge grassland ecosystem that stretched across continents.
Mammoths, woolly rhinos, all those guys, I always picture them trudging through snowy wastelands.
Well, the mammoth steppe, it wasn't exactly a winter wonderland. These grasslands were surprisingly productive, and the megafauna, they were a big part of that. Jag calls them ecosystem engineers. They weren't just passing through, they were knocking down trees, grazing, even fertilizing the soil. They shaped the landscape on a huge scale.
So instead of forests taking over, you had these huge grasslands, all thanks to mammoths.
Exactly. And here's where it gets really interesting. Grasslands and forests, they affect the climate differently. Grasslands actually reflect more sunlight, which can help keep the planet cooler.
Wait, so you're saying that mammoths going extinct could have actually made the Earth warmer?
It's a theory, a complex one, but it shows how everything's connected, right? You remove one piece, even something that seems insignificant, like a bunch of big furry herbivores.
Yeah.
And it can have ripple effects we might not even understand.
That's a bit unnerving, honestly. Makes you wonder, if something as big as a mammoth can have that impact, what about all the smaller life forms we haven't even talked about yet?
Well, that leads us to another fascinating point. Jab makes the hidden world right beneath our feet.
Soil. It's everywhere, but we kind of just take it for granted. What's so fascinating about dirt?
It's not JJSD. It's like this teeming city of life, more complex than most rainforests. I'm talking microscopic tardigrades, those cute little guys that can survive anything, to intricate fungal networks that go for miles, bustling ant colonies, all happening right under our noses, or I guess I should say our feet.
Plankton, right. I have to admit, I always pictured them as those tiny little specks you see under a microscope. Not exactly the planet-changing forces you're making them out to be. What's the big deal with plankton anyway?
Well, it's their sheer numbers, for one.
Yep.
And their role in the ocean's food web. I mean, yeah, individually they might be tiny, but put them all together, and you've got this massive amount of life. It supports a crazy amount of diversity in the ocean. Think about it, everything from those cute little seahorses to gigantic humpback whales, they all rely on plankton in the end.
Okay, so the foundation of the food chain, I get that. But you said something about them shaping the planet. How do these invisible little creatures have that kind of influence?
Scale and interconnectedness, those are the keys. Let's start with, well, the air we breathe. Did you know plankton actually help regulate Earth's atmosphere?
Wait, really? You're telling me those little specks affect the air we breathe? How is that even possible?
Photosynthesis, remember that. Plants taking in carbon dioxide, releasing oxygen. Well, a huge amount of the planet's photosynthesis, like almost half, happens in the ocean. And it's driven by phytoplankton, the plant version of plankton.
Whoa. So while we're busy thanking trees for cleaning the air, it's these invisible ocean creatures doing a lot of the work. That's kind of mind-blowing.
It is. They're sucking up that CO2, pumping out oxygen, basically influencing the very air we breathe all over the planet. And that's not even the half of it when it comes to plankton.
Okay, you've definitely got my attention now. What else are these, like, tiny titans of the ocean up to?
Well, let's talk about climate change. You know, all that extra carbon dioxide in the atmosphere causing global warming. Plankton might hold a key to helping with that.
Okay, I'm all ears. How can plankton help with climate change?
When plankton die, especially the ones with hard shells, like coccolithophores.
Say that again?
Coccolithophores, that's a mouthful. Anyway, when those guys die, their skeletons sink to the ocean floor. This process, it's called the biological pump. It basically traps carbon in deep sea sediments. It's locked away from the atmosphere for a really long time, like hundreds, even thousands of years.
So it's like this natural carbon capture system, but in the ocean. That's so cool how nature does that.
It really is. And there's more. We were talking about kelp forests, right?
Mm-hmm.
The rainforest is the sea. Well, they're not just beautiful and full of life. They're also amazing carbon sinks.
Okay, back up a bit. Kelp takes in CO2, like all plants do, right? But how does that make them a carbon sink? Don't they release it all back into the atmosphere when they die and decompose?
That's where it gets really interesting. See, when kelp dies, some of that carbon it's been holding on to actually sinks down to the deep ocean. And down there, it can stay put for centuries out of the atmosphere completely. It's like nature's way of storing carbon, taking it out of circulation.
That's amazing. So kelp forests are like these giant underwater carbon vaults. We should be planting more of them everywhere.
Jabr talks about that, actually. He mentions this company, Running Tide, that's doing something really cool with kelp cultivation. They're developing these special buoys, they're biodegradable, and they're seeded with kelp spores. They send these out into the open ocean.
Biodegradable buoys. So they're farming kelp in the middle of the ocean. I'm gonna need to hear more about this.
It's really clever, right? The buoys, they support the kelp and give it nutrients so it can grow really fast. All that kelp, it sucks up tons of carbon dioxide. And here's the best part. The buoys, they eventually break down naturally. So you've got all this kelp loaded with carbon and it just sinks to the bottom of the ocean.
It's like this controlled, targeted way to lock away carbon in the ocean. It's using the power of nature itself to fight climate change. This is exactly the kind of cool stuff Jabr's book is all about. We hope.
But it also makes the whole plastic problem even scarier, doesn't it? I mean, if we're messing with these delicate ocean ecosystems.
It does make you think. Jabr doesn't sugarcoat the impact plastic pollution is having. He talks about how it's literally everywhere now. The deepest parts of the ocean, the Arctic, even inside marine animals. It's a harsh reminder that our actions, they have consequences. Big ones.
It's almost like we're creating our own layer in the earth, but it's made of garbage.
That's exactly what Jabr suggests. He talks about this new kind of rock called plastiglomerate. Melted plastic fused with sand, shells, even bits of coral. They found it on beaches. It's a sign of how plastic is literally becoming part of the earth itself.
Plastiglomerate. Sounds like something straight out of a dystopian sci-fi movie. That's a wake-up call if I ever heard one. We have got to see to figure out this plastic problem. Not just for the ocean, but for, well, everything. Absolutely. Using less plastic, getting better at recycling, coming up with alternatives that actually break down naturally is a huge challenge, and it'll take all of us. But let's switch gears a bit. We've talked about life deep underground, life in the vast oceans. What about a force that we usually think of as destructive, but it's actually crucial for how ecosystems work?
Volcanoes, earthquakes. Wait, don't tell me. Fire.
You got it. Fire's been shaping the planet for millions of years. It can destroy, yeah, but it also renews. And it's tied to how life has evolved on Earth in a big way.
Fire, yeah. It's definitely a force of nature. I remember learning about how, like, some forests actually need fire to survive, like those giant sequoia trees. but I never really thought about it shaping the whole planet.
That's what Jabr really gets you thinking about. We tend to see fire as this, scary thing, dangerous, something to be controlled. But if you look at it from Earth's perspective, it's been around for millions of years. It's part of the system.
Right, like those controlled burns you hear about, where they intentionally set fires to help clear out the underbrush and make way for new growth.
Exactly. And Jabr talks about how indigenous communities around the world, they've understood this balance with fire for a long time, using controlled burns to manage the forests, keep them healthy, even make the land more productive. It's pretty amazing. They see fire as a tool, not just a threat.
It makes you realize how much we can learn from traditional knowledge, But we haven't always done a great job with that, have we? I mean, look at all these megafires we keep seeing in the news. They're just devastating.
Yeah, it's complicated. As more people started living in fire-prone areas, we started putting out fires, trying to stop them completely. And at first that seems like the right thing to do, but it actually messed with the natural cycle of fire in a lot of ecosystems.
So by trying to prevent the smaller fires, we've actually made it more likely for these huge, uncontrollable fires to happen.
Exactly. When you stop those smaller fires, you're basically letting all that fuel build up, dead trees, dry brush, all that flammable stuff. So when a fire does start, whether it's lightning or someone being careless, it can explode.
Wow, it's like we've tipped the balance of the system that was working for, millennia. It's a scary thought. And it seems like everything we've talked about, those tiny microbes, the giant mammoth, it's all connected in this delicate balance, and we're just starting to understand it.
And that brings us right back to Jabr's big question: is Earth itself alive? Is it just a hunk of rock? Or is it something more? Does it act like a living thing?
I gotta say, after learning all this, it's hard not to see the connections, how it all works together. It's like the Earth is breathing, growing, changing.
It's a powerful image, isn't it? And Jabr makes a good case. He points out how Earth regulates its own temperature, how it moves nutrients around, how it even heals after things like volcanoes erupt or asteroids hit. Those are all things we associate with living organisms, even if it's on a much bigger scale.
And when you think about how life has literally shaped the planet, from those early microbes putting oxygen in the atmosphere to the kelp forests sucking up carbon, it does make you feel like Earth is more than just a background. It's like it's part of this dance.
Exactly. And if we start to see Earth that way, as this living, breathing thing, how does that change how we relate to it?
It makes you think about our responsibility, We're not just visiting here, we're part of this incredible, intricate system. It's on us to keep it healthy.
Jabr doesn't shy away from the tough stuff, either climate change, plastic in the oceans, losing biodiversity. But he also talks about how humans are clever. We can learn from our mistakes. He talks about renewable energy, farming in sustainable ways, listening to indigenous knowledge. It gives you hope.
It does. We have a lot of work to do, but we're not powerless. We can change our relationship with Earth, go from this mindset of taking, to one where we're giving back, helping it regenerate.
It's about understanding that we are nature. We're all part of this amazing experiment, this incredible story of life on this planet. And what happens next? Well, that's up to us.
Well said. And that's a wrap on another deep dive. We hope you've come away with a sense of awe, a deeper understanding of how interconnected life on Earth really is, and maybe even a renewed sense of responsibility for this incredible planet we call home. Until next time, keep exploring, keep asking those big questions, and keep diving deep.